So if we start by looking at the diagonals, say that the diagonals bisect each other, then we have AE is congruent to CE and DE is congruent to BE. That's given, that's the diagonals bisect each other. Also, we have angle AEB congruent to CED. Look at the relationship of those angles. And then AED is congruent to CEB. Same relationship there. Those are vertical angles, which is why they are congruent. So within this parallelogram, we now have four triangles, AEB and CED, the top and the bottom triangle. AED and CEB, the left and the right triangles. And both pairs of those triangles are congruent because of side, angle, side. So that's what we're going to write down. AEB is congruent to CED and AED is congruent to triangle CEB. And we said side, angle, side. Since those triangles are congruent, all of their corresponding parts are congruent. This side over here on the left corresponds with that side on the right. AD and BC. Those are corresponding, therefore they are congruent. Also, up here, AB and CD are congruent because they're corresponding parts of congruent triangles. So they are congruent. Now, when you're doing proofs, the reason that we're going through and proving all of these theorems that we wrote down, if it's a theorem, if it's something that you've proved, you can use it. So you don't have to go through all those long steps. We don't have to show specifically that these sides are parallel, because a few examples ago we proved that if opposite sides were congruent, then it's parallelogram. We just showed that opposite sides are congruent, therefore it's a parallelogram because opposite sides are congruent. Now that's good enough reason. So now we're going to use all those properties that we just were working with and proving to solve for variables, similar to what we did in the 9.1. So if x is 7 and y is 4, is this a parallelogram? So if x is 7, that means that this top side is 21, the bottom side is 21, so those sides are congruent, so halfway there. And if y is 4, this side would be 20 minus 4, which is 16, and this side would be 8 plus 8, which is 16. So you plug it in, you would get opposite sides are congruent, which means it's a parallelogram. So yes, those values prove it's a parallelogram because opposite sides are congruent. So now we can plug in 11 for z. So that's 99 plus 19 is 118. And we can plug in 11 for z in the bottom right. 11 times 11 is 121, minus 3 is 118. So we have one pair of opposite angles. Now we'll plug in 4.5 for W. 12 times 4.5 is 54. 54 plus 8 is 62. And then 14 times 4.5 is 63. Minus 1 is 62. So yes, we have opposite angles are congruent, so yes, it's a parallelogram. We could also have shown that consecutive angles were supplementary. It would have just been a separate, different statement. 118 plus 62 is 180. So that would have worked out too. So for here, if A is 2.4, 7 times 2.4 is 16.8. And then 2.4 times 2 is 4.8, plus 12 is 16.8. So those opposite sides are congruent. Now, if B is 9, that's 90 minus 16, which is 74. And then 9 times 9 plus 25, that's 106. So we have these two sides, or these two angles, are consecutive angles, and they are supplementary, because 106 plus 74 is 180. So if those angles are supplementary, '74 plus 106 equals 180. So that means that QP and RS are parallel. And they are congruent. So we have one pair of opposite sides is congruent and parallel. That's enough to prove it's a parallelogram. That's one of our conditions. Another condition we haven't looked at yet is that diagonals can bisect each other, and that would be enough. So if the diagonals bisect each other, then the two halves will be congruent to each other. So plug in 6, that's 12 plus 2 is 14. Plug in 6, that's 24 minus 10, it's 14. So yes, that diagonal is cut in half, it's bisected. Y is 3.5, then we have 6 times 3.5 is 21, plus 1 is 22, and we have 8 times 3.5 is 28, 28 minus 6, 22. So yes, the diagonals bisect each other, so yes, it's a parallelogram.